Asia that separates two island chains by only about 100 kilometers. You can't see the other side, but early humans still eventually made it across, deliberately, in boats more than 60,000 years ago. And yet, elsewhere, humans stood on coastlines for tens of thousands of years staring at water they never attempted to cross at all. Same species, same brain, wildly different decision. Why? That's the question we're answering today. Because the story you probably absorbed somewhere along the way, that ancient humans were relentless explorers who pushed into every unknown the moment they saw it, isn't true. Not for the ocean. Humans crossed deserts. They crossed ice sheets that would kill a modern hiker in hours. They crossed mountain ranges that still claim experienced climbers today. But the open ocean, for the overwhelming majority of human history, was treated completely differently. It wasn't explored. It was avoided. And once you understand why, you start to realize that refusing to cross it wasn't fear in the primitive sense. It was one of the most sophisticated risk calculations our species ever made. Let's start with the actual problem, because the ocean is dangerous, undersells what's actually happening out there. On land, danger has a shape. A lion has a location. A cliff has an edge. You can see the threat, assess it, and respond. The ocean doesn't work like that. It's not a place with a danger inside it. The ocean itself is the danger, uniformly, in every direction, with no edge to retreat to. Step off a boat on land and you're standing somewhere. Step off a boat at sea and there is no somewhere. There's just water in every direction until there isn't, and you don't know which direction that is. Here's the biology of what actually kills you out there, because it's faster and more mechanical than most people assume. Hypothermia in open water works on a timeline that has nothing to do with how tough you are. Water pulls heat from the human body roughly 25 times faster than air. In water around 15 degrees Celsius, a genuinely reasonable temperature for open ocean in a lot of the world, a person can lose the ability to use their limbs within an hour and lose consciousness within a few hours after that. No amount of willpower changes that number. Your muscles simply stop working on a schedule set by physics, not by courage. Then there's dehydration, which sounds almost absurd given you're surrounded by liquid, but seawater is roughly 3.5% salt, well beyond what human kidneys can process. Drinking it doesn't hydrate you. It accelerates your death because your body has to expend more fresh water processing the salt than the seawater actually contained. Ancient sailors who drank seawater out of desperation weren't making an error out of ignorance. They were choosing a slower death over a faster one because by that point, both options were already terrible. And then there's the problem that doesn't get talked about enough. You cannot see land, which means you cannot navigate by the one method every land-based human intelligence evolved to use. On land, even in an unfamiliar place, there are landmarks. Rivers flow somewhere. Mountains stay in the same spot. Trails exist because other people walked them before you. The ocean erases all of that instantly. Every direction looks the same. The horizon is identical whether you're moving toward land or moving directly away from it. Get your heading wrong by a few degrees over a long enough distance and you don't end up slightly off course. You end up nowhere, forever, with no way to correct it once you're out of sight of the coast. Put those three things together: catastrophic heat loss, catastrophic dehydration, and total navigational blindness, and you start to understand why ancient humans looked at open water and made a decision that had nothing to do with cowardice. They were reading the actual odds. And for most of human history, the odds were terrible. So how did anyone ever cross at all? Because clearly, some did. Humans reached Australia by at least 65,000 years ago, which required crossing significant stretches of open water even during the lowest sea levels of the Ice Age, when land bridges connected far more of Southeast Asia than exist today. This wasn't an accident. Researchers who've modeled the geography of the region, a zone scientists call Wallacea, have found that even at maximum Ice Age land exposure, there were still multiple channels of open water, some over 70 kilometers wide, that any group moving from the Asian mainland toward Australia would have had to cross deliberately, with no land visible on the other side for at least part of the journey. That's not something you do by accident. You don't fall into the ocean and drift 70 kilometers in a survivable, deliberate way, arriving with enough people to found a population that eventually spread across an entire continent. This required boats, and it required boats built well enough to carry multiple people, plus food, plus fresh water, across a genuinely lethal distance. The earliest confirmed evidence of human seafaring on Earth belongs to whoever made that crossing, and we don't fully know how they did it because boats don't preserve well in the archaeological record. Wood rots. Reed rafts disintegrate. We have almost no physical remains of the actual vessels. What we have is the outcome. People arrived in Australia who could only have arrived by water. The boat is missing. The proof that it existed is an entire continent's worth of descendants. Sites like Majed Baby in northern Australia, with occupation layers dated to roughly 65,000 years ago, and the earlier stone tool evidence from Flores in Indonesia, which suggests hominins were making short water crossings possibly hundreds of thousands of years earlier than modern humans, complicate the story even further. Homo floresiensis, the so-called hobbit species, appears to have reached Flores despite it always being separated from the mainland by open water, even at the lowest ice age sea levels. That means some hominin, not even our own species, was crossing water barriers long before anatomically modern humans existed. Whether that was deliberate seafaring or repeated accidental rafting on storm debris is still genuinely debated among researchers, but either way, it pushes the story of hominins and water back further than most people assume. So if the technology, or at least the capability, existed even before modern humans to cross open ocean under the right circumstances, why did so many other human populations, staring at their own stretches of open water for tens of thousands of years afterward, simply not do it? This is where the social and psychological dimension becomes just as important as the physical one, because crossing open water isn't a decision an individual makes. It's a decision a group makes, and groups calculate risk very differently than individuals do, especially when the risk in question is existential. Think about what a failed crossing actually costs. It's not just the loss of the people in the boat. In small ancient populations, the loss of even a handful of individuals, especially individuals of reproductive age, could meaningfully damage a group's long-term viability. Now imagine losing an entire exploratory party, the strongest, most capable people, the ones most likely to have volunteered for something this dangerous, all at once, with nothing to show for it and no way for the rest of the group to even know what happened to them. They just didn't come back. No story, no warning, no lesson learned, just an absence. Compare that to a failed overland expedition. If a hunting party runs into a predator or gets lost crossing unfamiliar terrain, there's usually a survivor, a story, information that gets carried back and folded into the group's collective knowledge. The landscape of fear that shapes how humans move through dangerous territory depends on feedback. You learn where the lions are because someone saw a lion and lived to describe it. The ocean provides no feedback. Boats that fail simply vanish. There's no lesson to extract, no map to update, no story to tell around the fire that night. Just silence where people used to be. This is a uniquely brutal kind of risk, one that offers no data in exchange for its cost. And human groups, operating on accumulated generational knowledge the way we already know they did with fire, with weather, with predator avoidance, seem to have treated this kind of risk with appropriate extreme caution, not because they were unintelligent or unadventurous, but because the entire cognitive system that had kept humans alive for hundreds of thousands of years, observe, learn, transmit, adjust, simply didn't function against an opponent that swallowed the evidence. So when a crossing did eventually happen, whether in Wallacea 65,000 years ago or elsewhere later, it likely wasn't a single bold decision by a lone visionary. It was almost certainly the product of specific, unusual circumstances, a population under pressure from resource scarcity, with genuinely nowhere else to go, a visible landmark on the horizon during a rare period of exceptional atmospheric clarity, smoke from a distant volcanic eruption, birds flying a consistent direction at dusk suggesting land that made the destination feel less like a leap into nothing and more like a calculated crossing towards something. Groups don't gamble everything on pure faith. They gamble when the math finally shifts, even slightly, in favor of trying. Now here's where the story gets genuinely strange, because the timeline of ocean crossing across human history is wildly inconsistent, and that inconsistency tells us something important. Wallacea gets crossed by roughly 65,000 years ago. But look at the Mediterranean, a body of water dramatically smaller and less hostile than the crossing to Australia. Logic says it should have been crossed almost immediately by comparison. It wasn't. Cyprus shows possible, still debated evidence of hominin presence tens of thousands of years earlier than expected, and Crete has produced stone tools that some researchers argue could only have arrived by sea, potentially hundreds of thousands of years ago. But these remain contested, thin, and scattered. Consistent, established maritime culture, real boats moving real populations across real distances on a regular basis, doesn't solidify in the Mediterranean until much later, well into the era of anatomically modern humans with fully developed language, planning, and boat-building technology. A sea you could, in good conditions, cross in a single long day took dramatically longer to become a normal human highway than a genuinely lethal stretch of Pacific-adjacent water on the other side of the world. Geography alone doesn't explain that gap. Circumstance does. Meanwhile, the Atlantic and Pacific, genuinely enormous oceans, remained essentially untouched by deliberate long-distance human crossing until an almost unbelievably late point in the story. The ancestors of Polynesian navigators didn't begin their era of extraordinary long-distance ocean voyaging, crossing thousands of kilometers of open Pacific to find islands that represent statistical pinpoints in an empty expanse, until roughly 3,000 to 3,500 years ago at the earliest, with the most remote Pacific islands, places like Hawaii and Easter Island, not being reached until within the last 1,000 to 1,500 years. That's shockingly recent. That's closer to us in time than it is to the invention of writing. So the pattern isn't humans got braver over time in a smooth, gradual curve. It's a pattern of specific technological thresholds. Crossing Wallacea required nothing more than a raft or simple boat and the willingness to attempt a crossing where land might not even be visible from the midpoint. Crossing the true open Pacific required something entirely different. Sophisticated double-hulled voyaging canoes capable of carrying enough food and fresh water for weeks at sea, and most critically, a navigation system precise enough to find a target that might be a single island in an area larger than every continent on Earth combined. That navigation system, when it finally developed in Polynesia, was genuinely one of the most impressive intellectual achievements in human history. Navigators memorized the rising and setting points of hundreds of individual stars across different seasons and latitudes, building what amounted to an entire mental star compass with no instruments at all. They read ocean swells, distinguishing multiple overlapping wave patterns by feel alone, sometimes lying down in the hull of the canoe to feel the water's motion directly through the vessel, well enough to detect the presence of land beyond the horizon from the way it disrupted the water. They tracked the flight patterns of specific bird species, frigate birds and terns among them, that returned to land each evening, using them as living compasses that could extend a navigator's effective range by dozens of kilometers. They watched cloud formations, since a stationary cloud sitting oddly on an otherwise clear horizon often meant an island heating the air beneath it. This wasn't reckless bravery finally overcoming ancient fear. It was accumulated, precise, transmittable expertise, refined and taught across generations, finally reaching a threshold where the ocean's risk calculation flipped from catastrophic to survivable. Before that threshold was reached, refusing to cross wasn't a failure of nerve. It was the correct answer to the math as it existed at the time. Speaking of getting things catastrophically wrong, ancient explanations for why the sea behaved the way it did got genuinely unhinged in places. Several ancient Mediterranean and Near Eastern cultures believed the ocean was populated by literal monsters guarding its edges specifically to prevent human passage, not as poetic metaphor for real danger, but as sincere navigational information passed down as fact. Some ancient mapmakers marked unexplored waters with warnings that sea serpents, giant crabs, or waters that simply boiled would end anyone who sailed far enough out. And here's the thing, functionally, this wasn't even wrong. The information being transmitted, "Don't go out there, it will kill you," was completely accurate. The mechanism was fictional. The conclusion was correct. Ancient humans wrapped a genuinely sound survival instruction inside a story dramatic enough that nobody would ignore it, which, if you think about it, is a remarkably effective piece of risk communication for a species without formal science. Scare stories about monsters in the deep were essentially prehistoric hazard signage. Now let's zoom out, because the bigger picture here says something about how humans relate to genuinely unknowable risk. Every other frontier ancient humans eventually conquered. Cold, altitude, predators, disease eventually yielded to the same basic formula. Observe, experiment, fail safely enough times to learn something, transmit the knowledge, improve. That formula worked on nearly everything, because nearly everything gave you feedback. The mountain didn't disappear after it killed someone. The next group could see the body, understand the mistake, and adjust. The ocean, for most of human history, broke that formula completely. It consumed the evidence along with the people, and a species that had survived for hundreds of thousands of years specifically by learning from observable failure had, for once, encountered a frontier that refused to teach them anything except silence. That's why it took so extraordinarily long. Not weakness, not a lack of curiosity, a correctly calibrated respect for a threat that offered no lessons, only losses. And when humans finally did solve it, in Wallacea, in the Mediterranean, and eventually across the entire Pacific, they didn't solve it with bravery alone. They solved it the same way they solved fire and cold and predators. Through accumulated knowledge, refined over generations, transmitted carefully from person to person, until the risk that had once been unacceptable slowly, deliberately, became survivable. You've probably crossed an ocean yourself at some point, 35,000 feet up, watching a movie, mildly annoyed about the league room, landing on another continent in a matter of hours without a second thought about the physics of what just happened. That casual crossing exists because somewhere in the deep past, people who had every rational reason to stay on the beach decided, eventually, carefully, deliberately, that the water in front of them was worth the risk. Not recklessly, not all at once. But eventually, someone looked at that same impossible horizon your ancestors avoided for 100,000 years and decided the story didn't have to end at the shoreline.